Okay, we'll be doing our tutorial class now. So I'm recording the session as usual. So today we'll be doing some trend analysis of hydrological data using R. So let me first introduce the the data that we'll be using, the time series data for trend analysis. Okay, so let me share the data with you. Let me share the screen with you. Okay, so sharing screen. Okay, so this is the, can you see my Excel data sheet?
Yes, sir.
So you can see that there is a ER here. And then we have the AM flow, means annual maximum flow. So at a particular site, it is 219,001. So that means it is located in drainage division 2 and basin number 19 and gauging station number 001. So with the station ID, it really tells important things. So 2 is the drainage division 2. So can you tell me, anybody can tell me like where is the drainage division 2 in Australia? So drainage division 2 is on the eastern side of the Great Dividing Range. So it is on the coastal side of Eastern Australia, Southeastern Australia. It covers part of Victoria and part of New South Wales and part of Queensland as well, which is drainage division 2, which is the coastal belt of Eastern Australia, Southeastern Australia. And drainage division 4 is on the west side of the Great Dividing Range. So all the rivers in the drainage division 4, which are like in the catchment ID, that will start with 4. So they drains to the Murray-Darling Basin. So all these rivers, they end up in the Murray-Darling Basin. And you know the western part of Great Dividing Range receive smaller rainfall as compared to our drainage division 2. So in case of drainage division 2, all these rivers, they generally fall into the sea, like the Tasman Sea or the Eastern Sea, near the in the east of the Australian border. So in this station, we have data, annual maximum flood data from 1949 to 2018. So we have 70 years of data. So we want to see a trend in the data, in the annual maximum data. The first thing, we can do some exploratory analysis. We can do a plot.
Wait, sorry, sir. Where do you get that data from?
That is an important question, I think. This data is obtained from Ataur New South Wales website.
Is it included in the tutorial, under tutorial, on views?
I will upload this data in the tutorial. So at the end of the tutorial class, I will upload the data that I am using today, because I'm using the latest data, which is available up to like 2018 we have. So I'll upload the data in the tutorial.
Okay. Are we going to use this to work for tutorial today Are we
Yeah.
gonna use this?
That's right.
So shouldn't you upload it now so we can do the working out with you as well?
So you want to do the working out in R as well? I
Like,
think that might be a good idea. Yeah. Yeah. Okay. So let me explain the data and then I am doing that to you.
sure.
Okay. So, okay. Now let me upload it in the views and the tutorial data. I think that would be a good idea. So let me do it right now. Okay, just give me a minute. It will be done very quickly.
So why don't you show us how to access it, like on the website?
Sorry?
Why don't you show us how to get it from the website?
In the website, this data is not directly like annual maximum data.
Okay.
They give the data generally daily maximum flow, so you have to extract the annual maximum from there.
No worries.
One day I'll show you, like on I think in one of the lectures is the I'll be discussing the ARR data hub. So in
Yes.
that lecture, I show you how to extract this data from the Water New South Wales or Austin Bureau of Meteorology. I'll explain in that lecture.
Okay, sounds good. Thank you.
Okay, so let us so let me close it first because I'll not be able to do it unless I close it here. Okay, so you want to change save, yes, something change. Okay, so this give me a second, so I have to stop share first. Share stop. Okay. Okay, so screen sharing is stopped, which is good. So let me upload the data in the views. Just give me a second.
How will you get the data? Is it in the email too?
Oh, so for postgraduate students, I have to email the data. Okay, just give me a second. I'll do that as well. For undergraduate students who are enrolled in the subject, you can get it from views. So, and for postgraduate student, I am just sending by email attachment to you. Just
Okay,
give me a
thank you,
second.
sir. Thank you, thank you.
So, okay, I have to go to my views. I have to go to my account. Statistical hydrology. Learning materials. Tutorials. I think it should be in the tutorial 8, I guess. Yeah. That's right, yeah. So in this, so I have to build content file. So this is data 219.001. Okay, so that is the data. So I am browsing the local files. Go to the documents. Statistical hydrology 2001. Okay, so I have given data for one station and I'll do for another station because we'll be using 2 stations data today. Okay, so build content, another file, AMF data for station. submit. And also I'll give you some notes on this thing that what I be applying it today. Okay, so I'll put some learning materials as well here. Okay, so file, we'll say our notes on trend analysis. Our notes on trend analysis. So browse local files. Okay, so open and submit. Okay, so I have submitted, I have given you 2 data files and on notes that how to do the trend analysis using R. So all the students, you can download it. And now I am sending this by email to the PhD students. So our notes on trend testing and data files of 2 stations. Okay, so okay, so I think I have sent it by email to all the students as well. So did you get the data now?
Yes.
Yes, sir.
Okay, so okay, so let me share the screen with you again. Share the screen. Okay, so this is the annual maximum flood data for this particular station. So before we do the trend analysis, we just explore the data to see any visual trend there. This is not part of the process, but we want to see how it looks. So say we copy the data and go to another sheet. Okay, and then we can do insert and a trend, that's the ordinary trend of the data. And then we right click the mouse and add a trend line. And of course, when we are adding a trend line, we can select some option just to see the sign of the regression coefficient. So display R-square on the chart, display equation on the chart. So what is the regression coefficient here, the slope?
minus 0.5368.
So minus 0.5368. So it means that this line has a slope of minus 0.5368. So that indicates that it's a negative trend there. Is that right?
Yes.
But we are not sure whether that trend is significant or not. We are not sure about it, whether it's due to the random error or whether it's really there is a trend in the data. So that's why we have to do the hypothesis testing. And that is possible in R. We'll show how to do that in R. Okay, so what we do, we have to save the data in some particular way. How we save the data? File save as?
CSV.
So we have to save that as CSV file. So let's say 2199. I'm giving a here because I may have that file already in there. So I'll just put in an A there and I'll say CSV MS-DOS, CSV MS-DOS CSV. So I save the data as the CSV file. Okay, now the data is saved. So now I'll go to R. So I'll stop share this on here now. So now I am going to R. So let me share the screen of R with you. So this is the screen of R. So what is the first thing we have to do in R?
Directory change.
We have to change the directory first. So we go to file and then change directory, change dir, change dir. So I do change directory and then I have to locate my file. So it depends on where you have put your data. So in my case, I put it in, I have a long, so teaching EWS, statistical hydrology. Statistical hydrology, and then I have to go to the 2021 statistical hydrology, and then I have to go to our notes for students, and then I have to go to trend analysis. Okay, so now I have selected my folder. So this is important. If you don't do that, then you will not be able to work with that. So what is the first thing we have to do? You have to read the data file into our system. So in doing that, what we do, we say AMF 219.001. You can give any name on the left, but I am giving AMF annual maximum flow 219.001 station. And then we have to say read.csv. That is the command in R. You cannot change that. And then your data file name should be within the inverted comma, which is 219.001 a.csv, because I put an A in the name of my file, and header equal true. So my data has been read. So once my data has been read, then you always give this command first, attach the name of our file, AMF 219.001. So that is the attachment done. And now I can see what are the names of the variables in my file. Names, AMF 219.001. So we have here an AM flow. So can you see my my screen?
Yes, sir.
Yep.
Okay.
Yes, sir.
So you can look at the ER. If you type ER here, then you'll be able to see all the ER. If you type AM flow, you'll be able to see all this AM flow there as well. So now we have to select a package called trend. So some of the students have difficulty in R and they are not installing the package. When you start a R session, you have to install the package. So you see on the top there is called packages. So I click on that and then I have to say install packages. And first I have to select the host of the program. In this case, I will select Australia, Canberra as my host. And then showing me the list of all the packages that this Canberra site, they host it. So I need the package called trend. So I have to find the package trend from here. So there are so many packages in R and you can do so many things, unbelievable. And there are a lot of user manuals in R and there are a lot of YouTube videos. If you want to use particular technique, then we can use it. So this is the trend here. So I am using trend.
So what do you select, sir? Is it trend?
Trend, the software name is Trend, T-R-E-N-D, Trend.
Oh, okay, trend.
So there is another, available another trend like trend SR, like something. So what does those mean?
There are many different packages. Sometimes you can do the same thing with different packages, but each of the packages has a specialty in it. So I am using the software Trend. So
Okay.
there are some other software as well that can be used as well, yeah, to get the same answer. So I'm using Trend, okay, T-R-E-N-D, Trend. So did you find the trend in your computer? Anybody?
Yep.
Anybody?
Yeah,
Then
it's
what
in
you have
there.
to do, then if you want to use that package, then you have to say require, R-E-Q-U-I-R-E, require trend. So that means that I want to now apply the trend. So really, that's why I'm telling that for my analysis, I need a trend, which we call it by in R, that require trend. So require and the bracket the package that we want to use for the analysis. So now this package is ready for your analysis for your data for your computer now. So now we for the MK test, we just give mk.test. This is the command, we have to use it because that is coming from the user manual of that software, that package. So MK test, and then we want to do the trend of our AM flow. AM flow, which is our manual maximum flow. We want to see the trend of that data. So just we type mk.test within bracket AM flow. If you can write it down, please. Because you have to apply this software for the next station is there by yourself. So can I press now? So I am entering it and immediately you are getting a result that the interpretation of result is important because you have to understand interpretation of the result. And you see that in our class today, like in the Maan test, there is a Z, standardized distribution Z. And I told that if Z value is too small, that indicates a significant trend because you think the standardized normal distribution, left side of the distribution, and if you are going far away from the center, then it means that your Z value is higher. And higher the Z value negative, like how the left you are going, or smaller the Z value if you sense in absolute sense, then really, and this p-value is the area that is situated on the left of that z minus 3.1635. So that is the p-value. So that is the area of the normal curve on the left side of that point. And if that point, that p-value is 0.0015, which is less than 0.01. So that means that there is a trend in the data at 1% level of significance at least. Because when you do the hypothesis testing, we generally use 3 significance level: 1%, 5%, 10%. So if somebody is passing at 1%, he's passing 10% or 5% anyway. Because this is a stringent criteria. For example, if somebody is getting high distinction, that means that he already got credit and distinction. Otherwise, he cannot go to high distinction rank. So in this case, I can say that the annual maximum flat data at station 219001 shows a significant downward trend at a level of 1% or 1% significance level. Any question on this? So do you have any question, or is it clear to all of you?
Prof, why could you get the 1% significant level? Can you please explain it again?
Because when you do the hypothesis testing, as we mentioned in our lecture, that hypothesis testing is done with a particular significance level,
Yep.
which is generally 1%, 5%, and 10%.
All right.
Because this is a standard procedure in scientific practice in hypothesis testing, that we'll be using 3 significance level. 1% is more stringent. 1% means that it's a strong trend here. If it was 10%, it is a little bit weaker, but it's still significant.
All right. Thank you.
So if this p-value comes as 0.2, then the significant, like the level of significance is really, it should be at least 10%. So it's becoming 20%. So 20% is not good. It means that we can reject the null hypothesis. So null hypothesis H0 was there is no trend in the data, so data is completely random. But we are rejecting the null hypothesis, so it means that there is a trend in the data at 1% level of significance. Of course, it is really less than 1%, but really we will be using either 10% or 5% or 1%. That's why you have to tell the p-value. If the smaller the p-value, you are more confident in rejecting your null hypothesis H0. Any other question? Okay, now this is a tutorial class, so you have to do something, not me all the time. So I have given you data for another site. And for that side, please do your MK test.
Sir,
Yes.
so before you move on, like, can you like tell once more, like, if we get like this in the exam, to explain these values that we got, like the Z value and P value, like how would you like write it on the paper?
I think that's a very good question. So if like I give you this station and you get this kind of answer from R, then first thing you have to tell that your Z value is quite small, because it's minus 3.16, because if it is less than 2 even that is quite small. So it is because you know when you do the confidence limit, then if it is 1.96, then it's 90% confidence limit basically. So it is less than that even. So it is very small. And then your p-value is very small. So your p-value is less than 0.01. So you have to tell that this p-value is less than 0.01. So that means that our null hypothesis H0 of no trend is rejected at 1% significance level with this p-value. P is 0.001559. So you may say that there is a strong evidence that the annual maximum flood data of the site 219001 is showing a downward trend.
All right, so thank you very much.
Okay, so now can you do the trend analysis with the other stations data that I have given to you? Sorry? So you got the another station data I have provided there. So can you do this MK test for that station and tell me the p value and z value as well?
It's a negative 1.999. Yep.
So you're
For Z
getting
value.
minus 1.99 z value, is that right?
Yes, sir.
Z value is minus 1.99, which is quite small. And what is your p value?
0.047.
So 0.04. So that means that it is less than 0.01. Is that right?
Yep. No,
So what is that 0
it's
point?
more than 0.01. So
So what is the value? What is the value you got? 0 point?
0.047, 0.05. You could say it's more than 0.01.
Okay, so 0.047, is that right?
Yes, sir.
Okay, so it is really, you have to conduct now with 0.5. So you have a trend which is
Passes the
5% significance level.
Yes, sir.
There is a negative trend at this side.
Yep.
So let us wait for other students. I want to see that all other students, they can do it. And if some student cannot do it, then I can help.
Was it negative 1.98 and 58?
Yeah, 1.9858. Yep.
So minus 1.98, which is the Z value. So you have to say that this the Z value is minus 1.98. And what is your p value?
4.7%, so about 5%.
So p value is 0. P value is when you say the p value, don't tell it in a percentage, rather say p value is 0.047. Don't put it as a percentage, because this p value is the area of the normal curve on the left of your z value. So if you imagine a random, like a normal distribution, bell-shaped curve, your center is 0. Your z at the center is 0. So you're going to the left. Minus means you're coming to the left. And how far you're going? You're going minus 1.98 in that curve. And then the area to the left of that point is that p value. That's why the bigger the z value in terms of minus, so if I say minus 3.5 or minus 4 point something, there is really significant evidence that really there is a evidence that H0 is rejected. So it means that null hypothesis of H0, there is no trend, is rejected strongly at 5% level here. So only 2 students have done, is that right? Any other?
So there's several nil values in that data. Would that affect the result?
There are several
Nil values, 0?
0 value. That's right. It's very interesting question you have asked. This is the Maan-Kendall test. It's a non-parametric test. So the result is not affected by those kind of 0 values. Because that is the advantage of this kind of test. Yeah, so you can apply it. That's fine. But that's an important observation you have made. Yeah. So 0 means that in those years there have been some instrumental error or something. So they have not got any data. But really, when we want to do flat frequency analysis, we have to fill that gaps in the data by regression analysis or by some other way. So how many students have done it?
So I am doing, but my laptop is doing some technical problem. That's why it's a bit late.
Okay, what about Nilufa? Nilufa, are you doing it?
Yes, sir. I'm trying to do it, sir.
Okay, so I'm giving more time. So everybody, please try to do it, because it's giving everything, like you are reading the data and then you are doing an analysis, you are downloading a package. So it's really giving your fundamental steps that is needed in R for any type of analysis. Is Anwar Hossain here today? Is Anwar Hossain PhD student here?
I'm here.
Can you explain the result for us? Because you are doing PhD on trend analysis, so you might be more knowledgeable than any one of us.
Actually, my R is not working at this moment. I am trying, and
No, that's fine, but can you explain the result? Can you see the screen of R?
yeah, I can see the result that is showing. I mean, p-value which is very, very small, less than 1%, 0.001. So that means the area is very small. So that means the null hypothesis is rejected.
Very strongly. So it means there is a negative trend in the null maximum flat dot on that side.
Yes.
So there is a very strong evidence. And we
Very,
found
very
that
strong,
in our data that that was really showing a negative trend, but now with the hypothesis testing, we found that there is a strong negative trend there. So that's why p-value is very, very important, and also the z value. So when when Anwar is reporting his results, he's always putting that z value and p-value in his result. Okay, so can I move on, or you want to try some other student to try?
Give us 2 seconds.
Okay, so I can give some more time, and let us, if you need anybody need any helps, please let me know so that I can help you, because sometimes you may not do one step and then your program will not be working.
So I just want to ask, with a negative trend, like, does that basically mean that the magnitude of the AM flow has a decreasing trend as the years go by? For example, like as the years go on, it has a decreasing trend. So over the years, the AM flow is decreasing on average. Does it mean that?
I think you have asked a very significant question. If you look at that Excel plot that I prepared, if you recall, if you can recall that plot, you will see there is it's generally reducing. But what this kind of test is doing is comparing 1 year with the next year, and so on. And whether it's positive or negative, it's increasing positive, it's decreasing negative. And then it's telling, it's finding how many negatives, how many positives. So if there are too many negatives, that means that as compared to the previous year, it's decreasing. And there is more decrement than increment.
I'm saying you said that the zero values don't affect the results, but shouldn't it affect? Because say if in a year there was actually no rainfall, let's say it was actually zero, so it's a decreasing trend. because if we have 100, like say 100 magnitude flow for this year and next year it's 0, it's actually decreasing. So shouldn't it affect the trend?
You are right in one sense that might affect. So that's why before using this data, it will be better to fill that gaps if you want to get a true result. In my opinion, this will not change the result, but still the best approach would be because, for example, when Anwar is doing the trend, he is filling all the gaps before doing the trend analysis. But this kind of test, they even run if there is some gaps in the data, they don't bother.
Or is the software ignoring the
Software ignores those data, that's right. Okay, then let us do the Spearman's row test, the next test. Any other students got the result? Okay, so if then I'll continue with my Spearman, like my Spearman row test. So we have to upload a package again. So this time the package is COR test, core test, correlation test. So install packages. So I have to select the core test. So COR. So COR.
Hey, Professor, since we're on the topic of results, I was just wondering, I was looking through the tutorial and I couldn't see any of the other solutions, like for 4, 5, and 6 on the tutorial one.
So you mean the tutorial for 5 and 6?
Yeah, for 4, 5, and 6, there's no tutorial solutions.
Because we are doing the solution in the class.
Cool. Yeah, so you're not, yeah, that's fine. Then I was just wondering if you were going to upload them.
For test, so COR. So you can see here core test, COR, correlation test. It is written as COR test. So I'm selecting this test, core test. Can you write it down this? So I'm selecting this package, core test. And we say require. We have to say require. So now I don't need to read the data because I've already read the data and it's in my system. Is that right? Because I want to do the test for the same site I am doing. In my case, I don't need to read the data again because already the data is in my system. Is that right? And I can test that by telling my ER and my AM flow. So this is the same data that I am using, but if you are using different data set, then it might be different. So you have to read the data again. So I have the data there. So now for this Spearman row test, we have to say correlation test, core test. And then we have to have our ER and AM flow and method equals SPR sphere they have a space by M. So this is the command you have to use. That core.test within bracket ER, comma, AM flow, comma, method equal Spearm, SPR, M. So they have like highlighted in that way in the manual of the R. So that will really give us the result from the SR test. You can write it down. Okay, so we can put enter now. So it given that the Spearman's rank correlation row, the S value is 79672 and P value is 0.008097. So it's telling that since the P value is very, very small, we can reject the null hypothesis and we can accept the alternative hypothesis, which is that if there is rho is not equal to 0. So it means that it has, and you can see the rho value is there, minus 0.3939. So there is a strong negative correlation mean trend, and that is significant at least 1% level of significance. The same data set, we are applying two tests. One is the MK test, another is the SR test. And by both the tests, we are finding that the annual maximum flat data at this site has a negative trend at 1% significance level. When both the test gives you similar results, then you are more confident to tell that the annual maximum flat data of this side has a negative trend, significant negative trend.
So how do you exactly take that 1% significance level?
Because when we discuss the significance level, we have to tell only three significance level, 1% or 5% or 10%. Okay. So in this case, I am telling 1% because this is the strongest test when we do the 1% test. And 10% test is weaker.
All right. So in general, 1% significance level is better to be said rather than 10%.
That's right. That's right. Like if for a student to graduate from the university, if somebody is only passing and somebody is getting high distinction in all the subjects, so he is also passing, but he's getting high distinction. So if someone said that he got the degree with a GPA of 6 and HD for most of the subjects, that means that he already passed. He already crossed 50%, so he has much better than that. So when you say 1%, that it means that it's a very strong indication. And at the same time, you have to send p-value. If it's smaller the p-value, stronger your evidence is. Any other question or anything? Okay, now can you do your this correlation test for the other side? SR test for the other side, can you do it? You first download the package core test, cor.test.
It's giving a warning message that it can't compute the exact p-value with ties. What does that mean for the other side?
So it cannot calculate the exact p-value. So what is the p-value it's giving?
It's giving 0.04699. So 0.047.
That's happening due to those zeros in the data. So there are some zero values in the data, is that right?
Yes, sir. Yeah.
So if you can delete all the zero values and create another file and do the test and see what happens.
Okay.
Delete the zero value and the corresponding years as well, okay? And then, okay, then see what happens. So which one of these two tests are preferable? Anybody who has got any idea? If I have to use only one test, which one I should select? Is it MK or SR?
Probably MK.
Why is that?
Oh, you know the whether the trend is negative or positive.
So you can maybe you can even use the Spearman's one, the latter one, because it's using both year data and AM flow data. Like it's like checking both.
I think there has been no study that which one is better. Most of the people, they apply both the tests at the same time. And most of the time we have seen that in some cases, we have found that different hypothesis testing or hypothesis rejection by the two approaches in the same data set. In this case, it's agreed, but in some cases, we have found that it does not agree, the results of the two tests. In that kind of scenario, you have to make a decision and you may have to apply other tests as well.
After removing the zero, the p-value is not like increased by a lot. It's 0.6193 now.
Once you remove those zeros.
Yes, sir. It's 62%.
So did you make your ER chronological or your ER is jumping there?
So I just deleted the entire rows that had zero values. So the year
if you
and
delete
month,
that, that's a problem because then your ER is a gap, ER is jumping. Is that right?
So should I make the year like 1, 2, 3, 4 like that chronological?
That's right. If you make the year chronological and see what happens.
Okay.
So data preparation is very, very important in hydrology. So if your data is has some problem, then your conclusion may be completely wrong sometimes.
I'm trying several times, but in my RB, the both package is failed to download. There are some errors. I don't know why this.
Maybe which site you are selecting? Are you selecting Canberra or nearby?
Yeah, Canberra. I select Canberra.
Because Canberra is too far from Dhaka. So try to select some site near to you.
Okay.
So maybe you can select Cambridge or something. Or maybe India, there might be some site in India, I guess. Because it's trying to remotely connect.
Excuse me, sir.
Yes.
See, quickly, just a quick look on how did you import the data?
Yes. So mean that you, so first thing is that you have to save
made
your
the
Excel
CSV
file. Have you
Yes,
done
yes.
that?
Yes, sir.
Then you have to go to file, change directory, go to file,
Yeah.
and then change directory.
Yep.
Have you done that?
Yes, sir.
And then you have to select the directory where your data file is located. Is that right?
Yes. Yes, I did.
You did that. And then after that, you have to write a command. You have to write a command. So I can go back in or like by putting arrow, putting the arrow button. So you see, I wrote this command.
Okay.
AMF 219001. This is the object I'm creating. You can give any name if you like. Then read.csv and a bracket, and within inverted double quote, you have to give the name of your CSV file. So check the name of your CSV file in the directory. Sometimes your file name may not be correct.
It's the file we are having.
What's telling?
412050.
So what is telling? The file is not there or something?
So just give me 1 second, sir. So header will be T always.
Header T means true. So that means that
Okay,
your data
true.
has
Yep.
a name.
Yes.
So that's why header equals true, T for true. If you don't have any header in the data, then you don't have to say that. So did you find, can you read it? Is Amir here today,
Yes,
Amir?
sir.
Is Amir here today, Amir?
Oh.
PhD student Amir. Is Amir here?
Yes, sir. My computer can read the data.
Can read
Thank
the
you,
data
sir.
now? Okay,
Yes.
so once you read the data, then what you do, you go to packages.
Yeah. Package. Yeah.
You go to packages and select the Canberra site.
Yep.
And then you have to go to package again and then upload the like this on that core test.
Yeah.
Okay, do it and see whether it works.
Okay, thank you.
So any other student, any difficulty?
So even if you do the year in chronological order, you get the same p-value.
Yes, sir. It's the same high p-value.
What are you getting?
0.619.
0.619.
Yeah.
With the SR test. Yeah. That is a bit funny results. So ideally, we have to fill that gaps in the data by some regression analysis. I can show you how you can do the regression analysis between these two stations, and we can fill the gaps. I can show that now. Once we finish this, so is there any other student who needs help on this? Okay, so I'm going to Excel now to fill the gaps in the data of the second station. So I'm stop sharing now. So go to stop sharing. Now let us go to our Excel file. Okay, so let me share the screen with you again. So from here and then share a screen. Screen sharing. So let us open one of these sites because we have the gaps in this data. So you see there are a lot of gaps in this data. So what we'll do, we want to fill this gap. So I am going to another sheet. So I'll show how to fill these gaps. So you can see that we have data from 1970 to 2018. And my data is 412050. So ideally, I should select a site which has the same drainage division. So which is drainage division 412050. So I'll try to find a site because I have the data for most of the stations. So I'll go to my particular location and I'll try to find a site which is nearby, and we'll use that to fill these gaps. So just give me a second. Okay, so this is 412050. So I'll go to 412050 that I was trying to use. So I can see that there is another data there, 412063. So that is in the same basin because 12 is the basin number. In the basin number, I can see there are a number of stations there. So let me see if I want to use 63. Whether what sort of data I have for this side. So you see this side data is only up to 99, which is not good. So I don't like this data. So let me see another sites, 076. So this one has data again 1999. So it means that government closed the gauging station there. So what are the data for 412050? How long? Sanjay?
It's 49 years from
What is the last year?
2018.
18. So that's right. So we need a station where we have data up to 218 because we need more correspondence. So let us see 412096. So this one has up to 2002 only. Government closed many stations during that period. So I have another one there. So this one has also only 2001. So it means that in that drainage basin, we don't have any station having quite good length of data. So in that case, what I'll do, I'll go to another nearby. So I'll go to 411 because these basins are side by side. So if I go to 411 and 003, let me see what is the data there. So this one has better because this is the data up to 2018. So I'll be using this data. So I'll copy this data. And then I'll go to that Excel sheet where we have 412050. 412050. And then let me put it here. So now we see here that for this station here,
So some of them have the fourth column, which is like 00809. What does that mean, the fourth column?
Because this is the quality code of the data.
Yep.
So this is the quality code of the data, so delete. And this is the date on which date the annual maximum happened. So delete, because we don't need that for the time being. Okay, so now we see here, the data has now from 1979. So we have to make it, first thing what we have to do in gap filling is that we have to take the data same length. So 1979 to 2018. So I'll take this Control C and I'll put that side by side here. And now you see that there are gaps here. So my objective is to fill these gaps. So in doing the regression analysis, what I have to do is I need to have the corresponding data. So I'll delete this line from both sides. And also I'll delete this line from the both sides. And then what I'll do, I will basically copy this data and put it here. And I'm putting this data here. So that means that now I have the data for the two sides which are corresponding. You see, every year is corresponding to every year. Can you see that?
Yes.
So we want to fill these gaps, which is this station here. So that should be our Y. And this should be our X. So we are in the right way. So really we are doing a regression analysis between these two sides. So select this one here. So basically I'll copy this one and put it on the other side there to do the regression, because if it's side by side, sometimes multi-selection is a problem. So Control C and then put it here, Control V. Okay, so now I want to say this is my station 1. And this is my station 2. Okay, so just develop a simple regression equation and see what is the strength of the relationship between these two sides data. So go to insert and do this one here, this one here. And it seems to be not very good correlation. So this is always a problem for me. So we add a trend line and say display equation on the chart, display R square on the chart. So you see this, there is an increment, like if one station increases, another station increases, but the correlation is very weak. Is 7% correlation only. Of course, you can use it for your data in filling, but accuracy will be quite low. So, but I'll show you with this because we have to do maybe correlating with rainfall rather than stream flow, or we may have to find a nearby station where we get better R square. This filling gaps is not easy. So, but let us try to use this relationship to fill the gaps of those sites. So our relationship is that Y equals 153.89 plus 1.5 39 of x. So that means that our so let me see one thing. So we are trying to fill the gaps of the station, where the last data was 67. So whether the equation is correct or not. Let me see the sequence of the equation. So I think we have done x and y in the opposite way. So really, we want to fill in this case here. So that is our y, is that right? That's right. So we know this one for those sides. So we need the corresponding values for these years for the other stations. We should not have deleted those rows there. Okay, so let me find those values again from there. So it was for, I think to this one here. So let me copy this data again and go back to that sheet there.
Excuse me, sir.
Yes.
So can I please leave the class now because I have a quiz coming up soon?
Yes, you can.
But what about the attendance, sir?
Gokhan.
Yeah, all good.
I think Gokhan has taken all the attendance, I guess.
Yep, all good. No worries. It's done.
Okay, all right, sweet as. Thanks, sir.
Thank you.
Okay, so we can see that the particular year 2004. So for 2004, what is the data in this station? 19.508. So our one, so x1 value is 19.5085. (2004) is gap, so 2005. So really we have to find out these values here. So how many? So 4, 1, 2, 3, 4. So this is our control C, and we have to put that in that equation there basically. Control V, and also there are gaps in another 2009 to 2011. So 2009 to 2011 is here. V, Control C. So it's coming here. So now basically our equation, I want to find out the y value, which is my equation is y equals 153
0.89
0.89
plus
it's doing something very
1.5039.
funny. It will not very good results. 1.5
039
39 times this value.
039 5039.
Okay, just I'm doing it. Okay, just give me a second. So 1.5039.
Yeah, I see that.
Okay, so in the equation is 0. I wrote it 539. Okay, so these are the values here that we are estimating. So now if we want to put these values here, so first 4 values is coming from here. Control C. And I can put it here as a paste values. So these are my field data here. And similarly, the next 3 coming as Control C. So this is my red values here again. So now this is the reconstructed data for our site where I have filled the gaps by regression.
So at this moment, the question might be arise how accurate our filling data is.
So I think I have done some mistake here because I think we have to select the, yeah, that's right, because R square is very low. Just I'm showing an example here how you do it. So you have to find better R square. So you have to try with many different stations and see which station is giving you the best R square, or you may have to correlate with rainfall. So data gap filling is not easy job. It's really very troublesome. So I think I have done a mistake here because these values should be as a
special
as a values. So now it's better. Okay, so these are not very accurate in my opinion, but it can do our job for the time being. So is this clear how you do it, the gap filling?
Yeah, it's clear that how we do our gap filling data gap filling. So, but the question is the accuracy point.
Yeah, you have to improve your accuracy. I told that already.
Yeah. So when we didn't find any basin that we are trying to gap filling data, so that in that case we can choose another basin. Okay.
Nearby basin, because I could not find anything in basin 12.
Yes, same basin.
So I went to basin 11.
Yes.
And you have to see how far it is as well. You can find because you have the latitude and longitude. So you can calculate the distances between stations. If the distances are too far, then your like R square will be smaller anyway most of the time.
Yes.
So better is to use some rainfall, because if you have some rainfall stations near to your gauging station, then if you use rainfall station to do the regression, that is generally better most of the time. Okay, anyway, so I'm just giving you an example how to do the gap filling. And the students who are doing the honors thesis or PhD in this kind of area, most of the time we have to do a lot of gap filling. I did a lot of gap filling in my PhD research, and I use many different approaches to do the gap filling. And I spent around a year time to prepare my database for my PhD research. The first year I did my literature review and comparison of different things. And then second year completely, I had to spend the whole 1 year to get my data, both the stream flow data and the catchment characteristics data. I have to measure the data from using maps, topographic maps manually. And then next 1 year, I did the analysis modeling. And then following 6 months, I wrote my thesis. So I took 3.5 years to complete my PhD. So data preparation takes a long time in PhD research. Sometimes honors research as well, but sometimes I give you the data, some of the data, because I'm doing research in this area for many years. So I have a lot of data, so sometimes it's useful. Okay, so now let us do a analysis of the MK test and or SR test with this data. What happens? So I'm copying this, and really I am going to another sheet there. So this is the field data, so I'll save it. File, save as. So I'll say 412.050. I'll say B. Just I can give any name, but I'm giving B here. And I want to save it as MS-DOS. CV, CSV, MS-DOS file, and I save it there, file there as well. Okay. So now I am going to R. So I'll stop share with you, and then I'll go to R. So stop screen share again, and I'll go to R. So can you see my R screen here?
Yes.
So basically, I will write AMF 412.050 equals read.csv, and then within the inverted comma, my file name was 412.050 b.csv, close the inverted comma, and header equals true. Okay, so AMF 412.050 equals read.csv 412.050 b.csv header 2. So it seems to be right. So I put it there. So now I can really see the names. Of course, names is attached. ATTSC is attached. 412.050.
Sorry, it should be AMF.
You're right. You're right. AMF. That's the object. AMF 412.050. So always check your command. So attach AMF 412.050. So that's correct. Attach. Okay. So then we can read. We can really say what is our AMF flow. So I think there will be a problem because our AMF flow might be at the beginning of. Okay, so let me see str or names. Let me see NAMS names of the AMF 412.050.
So you read 512, sir. So you read file name 512. It should be
AMF 412.050. 05, that's fine, that's correct. Yeah. So first is the ER and the second is the AM flow. So we are fine with that. So we can say ER and we can say AM flow for this station. Okay, so that's now the data is ready. So we can now use our correlation test or the SR test. So let us do it now. Core.test. And our ER AM flow and method equals single quote SPEARM. So I have forgotten thing here. Okay. So core.test.
Sir, after AM flow, Is it comma or dot?
I think you're right. It should be comma, like ER AM flow, and it should be comma. So always when you type your command, you just always check, because otherwise there might be mistakes. So quad.test, and then ER AMM flow, comma method is this SPARM. So it looks everything right now. So I can enter it. So p-value is 0.82. So it means that the trend, we cannot reject H0. So in this case, we can see we are getting different results. Let us do the MK test here and see what we get. So mk.test with the AM flow. So again, we got the very similar p-value, so there is no trend. So we cannot reject the null hypothesis. So that means that there is no trend at this site, at the statistically significant 10% level or even. So that is the conclusion that we are coming. Any question? So no question. So it means everything is clear to everyone. It's good.
Just to confirm, it's under 5% is where you reject the nil hypothesis.
10%.
10%.
Yeah.
Right.
So we say that at 10% level, there is no significance here. And p-value is very high. So it means that really very strong. I am very confident there is no trend, because you can see p-value. If the p-value was close to say 0.1 or 0.12, something like that, then there's a doubt. But in this case, your p-value is so high, because you see that has created the problem, because that error level there, that is when we fill the gap, and I saw that most of the values are very high, because that regression equation is only 7% coefficient of determination, which is very poor equation. So that is affecting your result. So this result is really is a problem of your error into gap filling, and that is reflecting here. So is it clear? So to be honest, what I'll do, I will really curtail that site where the gaps begin, and I'll do the test. Okay, let us do that. The time is almost up, but let us do it. With hydrology subject is problematic. Like it's sometimes your data, like if it can give a lot of misleading things. So I'm going to my Excel there. So where was the gap at the beginning? So we can do the trend analysis from 1970 to 2003, okay? And I will not do after that. Okay, so let me share this in new share. So we see that there is a gap here from 2004, is that right? So I'll discard all the data from 2004 to onward. So really, I'll delete all of this data. And I'll do a test on this data, which is 1972. How many years of data we have now? 25 years of data. So let us save it as a
34 years of data.
File save as C. And ms.csv, so I do save as that. See? Okay, so now we go back to R. So stop share here. And now I'm coming to your screen share again and go to our R. So when I'm coming to R, then just I go back. And I am reading this on, it would be, sorry. So it will be only C, is that right? Everything is same. C.
Left side same.
Sorry?
The previous name AMF 421050, it might be same.
We are making the same because it's object. So we are creating the same object, that's fine. But our input data is different. So now this object is different. Okay. Okay, so now let us do that test again. So that with same command basically for test.
Same value, I think.
So p value is 0.82. So really the signal is quite weak in this case. So really now we are sure that really the trend is not significant. So finally, one thing I want to do is we want to go to Excel and we want to do a plot and see how big the how is the looks the plot. Let me see. So I can do the insert and series like this, and you can see this is random, quite random. Add a trend line and come here, say.
So it is almost level.
So you see that's why, although it's your coefficient of X is minus, so it's a negative trend, but it's not significant because you can see it's almost horizontal.
Yeah, I think it's almost no correlation.
No correlation because like that's the hypothesis testing is doing it. Hypothesis testing is telling that of course it's a negative, but it's not significant.
Yes.
From a statistical point of view, it's not significant. So I think really we have done a very good example today. So I have shown you how to do the MK test, Spearman row test, and I did how to fill the gaps in the data, one example. And then we did the test with the 2 stations and number of different OS. So I think you have a good understanding of doing the trend analysis. And there are many other ways of doing the trend analysis. You have to do Monte Carlo simulation. There are many other advanced techniques, which you probably will do at one stage of your career, probably if you're working in this field. Particularly Ataur Rahman, he's doing PhD on this field, so he'll be doing much more on this theme. And the impact of climate change, relationship of this trend with the climate indices, and he'll be doing a lot of simulations with many stations data all over Australia. Okay, so that's all from me today.
Professor, one of the questions asked, do they responsible about the filling data in the exam?
Sorry, what's the question?
So they're asking that in the exam, are they responsible for the filling the missing data?
No, I'll not give any data that requires filling, no.
Okay.
Yeah, that would be good for us.
Yeah, because then it will take a long time and it's really confusing during exam time.
Yeah, and it will take time to play around the data to find out the
yeah. No, I'm very mindful about it because that will create a lot of confusion. Any other question? So Gokan, you have taken the attendance?
Yes, sir, all good. It's
okay,
done.
so Gokan, I think you have understood the trend thing now, is that right?
Sorry?
But you did that already before.
Sorry?
You have did a lot of trend, I think, in your thesis.
Yeah, I did.
Yeah.
Yes.
So you are using R or MATLAB?
None of them. I'm using different. I used in MATLAB some part, but I didn't use R in my trend analysis.
Okay, okay.
And yeah, I use MATLAB and Excel and some integrated software with Excel.
There are many software for this kind of trend analysis.
Yeah.
And some of them, they can do some more tests like the sense point test, and there are other tests there. So I think we can use the sense point analysis and trend in one of his chapters. Okay, I think that's all from me today. So we can stop sharing. And end the session, unless anybody has any question. So Gokan, did you look at the chat?
Yes, sir.
Any more question from chat?
Yeah, I asked you. One of the students says, "Could you please upload the video today?"
I'll upload the video, of course. Sure.
Yeah, I didn't see any others. The students mostly writing their, name and ID. I told them you don't need to write, but it's all good.
Oh.
I didn't see another question.
So I had a question regarding the AM flow, those data files. You said that the fourth column is the quality parameter. I've seen sometimes that there's a -1 value there. So does it mean anything significant if there's
Yeah, this is significant because this kind of quality code tells that there are different code has different meaning. So sometimes the instrument fails, so they have tried to constitute the data by some way.
Yep.
So sometimes there is estimated data. So all this quality code is an important issue, and the student who has prepared this data for us, this data is coming from our ARR project. Basically, we started this process in 2003 and 4. When I joined Western Sydney University, then I was given the responsibility to upgrade the ARR regional flood methods at that time with a big team. So then we started preparing this data, and at least I would say at least 15 students have worked in this area to prepare these databases progressively with time. So most recently, this data has been updated by my PhD student, Laura Rima. She's a PhD student in second year, end of second year or something. So she has spent around 6 months time to upgrade the data because our ARR data is up to 2011. And then from 11 to 2018, Laura has done it. Now Anwar is doing upgrading some more years there, 2 more years. And hopefully Ali Ahmad will be doing some upgrade as well. So every time, this is a progressive step that we do. And I generally closely monitor the infilling of the gaps and these kind of things to some extent to ensure the quality of the data. So there are a lot of issues with the data quality, and if you don't understand your data well, then the design or the conclusion you are making, you can make a lot of wrong conclusion. So you have to understand your data properly. Okay, I'm ending the session now.
Thank you, sir.
Thank you.